Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. Beneath your feet lies a memory of motion. Not a loud memory, not something that startles, but an old, grounded remembering, a kind of knowing that the land has carried for longer than history, so longer than stories, longer than time spoken aloud. This is California, where the ground wears the scent of orange blossoms, the shimmer of surf, the hum of traffic, but far below that music, below the concrete and the canyon trails, the earth is remembering something much older than cities. Here, the crust is not a solid shell. It's a mosaic, a collection of fractured thoughts pressed together, floating above molten dreams. And through that mosaic, a serpent winds its slow body. The San Andreas Fault. It's not a crack, not really. It's more like a boundary between moods, where the Pacific plate slides past the North American plate. It's not in fury, okay, but in glacial patience. This fault has moved mountains, literally, and not in moments of dramatic quaking alone, but in millimeters, in inches, in the kind of slow motion you can only see if you measure it across lifetimes. It hasn't always been quiet. Sometimes it shudders. Sometimes it jerks the land sideways, rips through farm fields, tilts fences, scatters shelves in kitchens that didn't expect to be rearranged. But for most of its life, it waits and hums. You might think of the Earth's crust as a lid, rigid and resting, a flat sheet laid over molten stew. But it's more like broken glass floating on soup, each plate bumping, grinding, drifting, okay? When where they meet, they don't sit still. California is one of those edges. The Pacific plate doesn't want to stay put, moves northwest, while the land to the east, the North American plate, holds a slower line, and so the edge crumples, twists, stretches, breaks. But most days, it simply holds tension. It's like standing beside someone holding their breath for a century. You don't know when they'll exhale. You only know it's coming. Below you, faults run like rivers in the rock, hidden until they move. They're not just under San Francisco, or Los Angeles, or Palm Springs. They stretch under deserts, beneath vineyards, between the roots of redwoods and the bones of hills. You can drive over them, build homes on top of them, never feel them stir, but they're there, always adjusting, always aware. Geologists use words like slip, creep, displacement, caught. What they're describing is a kind of conversation in stone. One block of earth says, "I need to move a little," okay? The other replies, "Not yet." This exchange continues, endlessly quiet, measured, rarely shouting dot until the tension grows tired of waiting. Even now, at this very moment, tiny tremors move under the state. You don't feel them. Your dog doesn't bark. The lamp doesn't sway. But the earth adjusts itself, micrometer by micrometer, and each adjustment is a reminder. This land is alive, not in a mythical sense, but in the real, rhythmic way that rock under pressure becomes motion. There's a kind of beauty to this awareness, knowing that below you, the ground has its own breath, its own clock, its own quiet pulse. You walk through cities with coffee in hand, wondering about deadlines and errands, and the ground watches, waits, holds tension like a coiled spring in its oldest muscles, not with anger, not with threat, just with the inevitability of memory, because this is not the first time Earth has waited to move. If you could see below the surface, if your vision tunneled through soil and stone, you'd witness this poetry firsthand. You'd see scar tissue from past earthquakes. You'd see layers of sand and sediment folded like bed sheets over restless shoulders. You'd see deep faults branching like tree roots, reaching toward the molten core like they remember where they came from. And in that underground theater, No act is ever truly finished. Scientists plant instruments deep in the soil. Seismometers, GPS sensors, fiber optic cables. They listen, they wait. They try to catch the smallest size of Earth. Sometimes they hear a chirp, a sudden ripple of energy racing through the crust at thousands of miles per hour. Other times, it's just a deep, persistent hum, the kind of low-frequency vibration that makes no sound, but never truly stops. This is what the Earth sounds like when it remembers how to move. The sand, Andreas Fault, gets all the headlines, but it's not alone. There's the Hayward Fault, quiet but capable. There's the Garlock Fault, stretching silently across the Mojave. There are offshore faults, hidden under waves and seabed. There are blind thrust faults, buried beneath the LA basin, invisible until they speak, and each of them holds a history, a signature, a mood. So why does this matter? Why whisper about the ground while the surface stays still? Because every story worth listening to starts in silence. The ground beneath California isn't angry. It's not dangerous for the sake of danger. It's just full of energy, full of memory, full of movement, waiting for the right time to stretch. And when it does, it won't be a surprise to those who've been listening. Tonight, as you fall asleep, the earth beneath you doesn't sleep. It shifts slightly, okay? It adjusts its weight. It thinks in tectonics, dreams in faults, and breathes in millions of years. And you sleep above that breath, warm, unaware, but somehow connected to it all. The earth does not shout. It doesn't warn with sirens or flashing lights. It doesn't wave its arms in panic. It simply shifts quietly, deliberately, without asking permission. And if you're not listening, not really listening, you'll miss it. Because rocks, you see, don't scream when they're under stress. They creak, they swell, they hold in their pain like old bones in winter. They are the introverts of geology, stoic, silent, but full of history. In California, the crust is a patchwork quilt of tension. Millions of years have stitched these rocks together and pulled them apart again, somewhere deep beneath your feet, okay? Miles below the vineyards, beneath the neighborhoods and canyon roads, okay? There's a kind of ancient conversation happening. Rock presses against rock, layers flex and resist. Grains of quartz grind together like teeth in a dream. And every once in a while, that pressure lets out a whisper, a signal, tremble, a tiny exhale from a stone that has held its breath for centuries. You might think an earthquake arrives suddenly, that it comes out of nowhere. But the earth never forgets what it's building toward. It lays the groundwork quietly, visible shifts, strains that build, bit by bit. The signs are all there, but they are written in a language that takes patience to read. Take, for example, the slow tilting of land. You wouldn't notice it on your morning walk. The sidewalk seems level. The trees don't lean, but to a GPS satellite circling overhead. There is a difference of millimeters over time. A ridge might lift by a hair. A valley might sink ever so slightly. The earth breathes in topographic size, too slow to see, too important to ignore. These movements are not guesses. They are data, numbers with purpose. Coordinates that shift like old memories being refiled. Scientists track them constantly, not because they expect answers today, but because they know the earth speaks in trends, not moments. A mountain doesn't rise in a single gesture. It rises in a lifetime of nudges, and so they watch, and measure, and wait. Then there's the matter of heat. Below the crust, the mantle simmers. Not in boiling rage, but in a steady, pulsing warmth that never dies. Sometimes that heat rises, not in lava, but in gentler clues. Soil temperatures creep up. Hot springs change their flow. Steaming vents appear in places that were once dry, and while tourists may see them as oddities, as quirks of the Earth's design, Scientists see something deeper. They see warmth trying to speak, a message in the moisture, a nudge from the deep. Places of the world, rocks, can also change their electrical properties under pressure. Yes, rocks can feel stress, and when they do, they shift the way they carry charge. This is called piezoelectricity, a phenomenon where squeezed minerals like quartz release tiny electrical signals. You can't feel it in your shoes, doesn't light up the sky, but it's there, an invisible spark from a world you rarely touch. In the days before certain earthquakes, animals sometimes behave oddly. Birds fly in tight circles. Dogs refuse to settle. Cats vanish. Perhaps they feel these signals, the Earth's subtle alarm bells, long before our sensors do. Water, too, has its say. In some regions, groundwater levels fluctuate mysteriously in the days before a quake. Not from rain, not from drought, just from something beneath, shifting the pressure of aquifers like a hand gently pressing under a sponge. Wells run dry, then refill. Streams darken, then clear. It's not magic, it's motion. The land is adjusting itself, and water responds. There are also radon gas anomalies. A rise in radon levels, a radioactive gas naturally found in soil, can signal changes deep underground. It doesn't smell, it doesn't glow, but it leaks upward when fractures begin to form, like a breath escaping through a crack in an old wall. These signs are not prophecies. They are possibilities. They don't say when. They only say, watch. But perhaps the strangest sign of all is silence. Not in the literal sense, but in what seismologists call seismic quiescence. A place that once had tiny tremors every day suddenly goes still. No more flutter, no more twitch, and that stillness is unnerving, because sometimes when the earth goes quiet, it's because it's winding up. Not always, but enough to listen harder. It's like watching a sleeping animal suddenly stop snoring, and you wonder, is it really asleep, or is something about to wake? In the end, Earth is not trying to frighten us. It does not threaten. It simply continues its dance. The push and pull of plates, the cooling of its core, the pressure of its own immense memory. And we, fragile and brief, build our lives on top of this sleeping language. We plant vineyards, we raise buildings, we name the hills, we pave the valleys, all on a surface that remembers being molten, that remembers moving, that remembers everything. Some people find this unsettling. Others find it beautiful, because there's a kind of serenity in realizing we are part of something so old, so vast, so indifferent to panic. The earth does not need to be feared, only understood. Its warnings are there, quiet as breath, patient as stone dot, and if we listen, if we learn its rhythms, its pauses, its small tilts and tugs, we might not control it, but we can walk alongside it, gently, as guests who finally learned how to listen. You don't need to hear every whisper to fall asleep. Just know that below you, the ground holds its peace with care. It moves with meaning. It waits with purpose. And tonight, while your ceiling stays still and your world above remains soft and quiet, the earth continues its slow, thoughtful conversation far below your dreams. You don't have to follow every word. Stressed. The planet will keep speaking, whether we listen or not, beneath the surface of your city, beneath the streets and subway tunnels, below the bedrock and bones of forgotten rivers. There is a place so distant from light and air that it exists only in pressure and heat. It is not hollow. It is not fire. It is not what childhood stories of lava would have you believe. It is heavier than memory, slower than thought, and it moves, but not in any way you've ever seen. This is the mantle, the silent engine of the earth, a layer of rock so dense and hot that it forgets how to be still, but remembers never to be fast. Most people imagine the earth as a crust, then liquid magma, but in truth, the mantle is not molten. It is rock solid, Mostly, but under so much heat and pressure that it behaves like something else entirely. It flows, but it does not pour. It shifts, but it does not crumble. Imagine honey made of stone, molasses with the weight of continents. It drifts upward in slow spirals, cooling as it nears the crust, then folds back down into itself over millions of years. You are alive for a flicker. The mantle moves through lifetimes. There are convection currents inside it, like weather, but older. Like ocean waves, but buried in silence. Heat from the Earth's core rises upward, lifting sections of mantle the way warm air lifts clouds. But nothing here is soft, and nothing here forgets how long it's been waiting. A single cycle, a complete circulation of one mantle plume, might take 500 million years. That's before language, before mammals, before fish with jaws. The stone inside your planet has been rising and falling since your continents were scattered like puzzle pieces. There are places where the mantle rises faster, not fast to us, but fast to Earth. These are called mantle plumes. Imagine a column of rock that stretches from the outer core all the way to the crust, slowly swelling upward like a buried geyser. It's pressing gently against the ceiling until it finds a crack. When it does, volcanoes form, islands appear, mountains bubble out of ocean floors. New land is made by the breath of something you will never see. Hawaii began this way. A string of islands, each born from a single deep breath of the earth. As the tectonic plate drifted, the plume stayed still, and so the islands formed in a line like footsteps left by stone, crossed the surface of the sea. There are others, Iceland, Yellowstone, Galapagos, all with hot roots that go deeper than imagination, anchored in the slow, old heart of the planet. California sits on a different kind of puzzle. Its land is not rising from a central plume, but torn between two massive tectonic plates, the Pacific Plate and the North American Plate. The mantle here isn't content. It stirs, it twists, it resists the neat flow seen elsewhere. Here, the mantle shifts sideways, dragged by the motion of plates above it, and that sideways tension, that grinding pressure, is why the surface quakes, why the land splits, why the mountains are young and sharp in some places beneath California. The mantle is doing something stranger. It is thinning. Scientists have discovered that in select pockets, lithosphere, the stiff outermost shell, is peeling away from the softer mantle beneath. This creates a sag, like a roof beam losing its support, a place where the crust weakens, quiet wound beneath the landscape. What happens then? Heat rises, magma may collect, volcanic fields form, not violently, but over eons. The land breathes more deeply. People above, for the most part, continue their lives unaware that the ground is slowly relearning how to stretch. There's a strange comfort in knowing that something so immense can move so gently. The mantle does not tremble like a leaf in the wind. It does not break like a branch. It moves the way dreams shift, subtle, slow. It's difficult to trace until you realize how far you've gone. The continents ride on top of this motion. We call it plate tectonics. But it's the mantle that powers it all. The earthquakes, the mountain building, the seafloor spreading, they're just surface symptoms of the deeper, older choreography unfolding beneath. Sometimes this movement leaves scars. A rift valley, a mid-ocean ridge, a belt of volcanoes wrapped like a necklace around the edge of the Pacific. Sometimes it leaves nothing visible. A change in temperature, a shifting of magnetic fields, a whisper in gravity. There are satellites now that can detect the swell of the mantle by measuring slight bulges in the Earth's shape, like reading a bruise beneath the skin of a planet. But for most of history, we knew nothing. We guessed, we wondered, we blamed gods and giants and curses. Now we know better. And the truth is even more humbling. The Earth moves, not out of rage, but out of need. It circulates its warmth like blood through unseen veins. It presses upward, carving out continents while we sleep. So tonight, when you lie down, remember, there is motion beneath you, but not of the kind that should keep you awake. It is not coming to break the surface. Hey? It is not knocking at your door. It is the ancient murmur of the mantle's slow drift, a reminder that even the most solid things are still learning how to change. Let it calm you. Let it remind you that pressure can exist without violence, that movement can be measured in patience, and that the ground beneath you knows how to carry weight without collapse. Just rest. The earth is not in a hurry. It never has been. Not all movement beneath the earth is loud. Some of it is patient. Some of it rises like a slow breath through layers of time, and some of it doesn't go up or down the way you'd expect. In California, the ground has begun to behave oddly, not with shaking, not with splitting, but with something gentler, stranger. Parts of the land are rising, other parts are quietly sinking. No fault line explains it. No human action fully accounts for it. The surface is reacting to something deeper, something old, something waking slowly beneath the crust. The Central Valley, for instance, once an inland sea, has always been soft beneath the feet. Its soil, a mixture of clay and ancient silt, remembers the weight of glaciers, the flow of forgotten rivers. But in recent years, satellite data has shown entire towns gently settling downward. Not dramatically, not like a sinkhole, but inch by inch, month by month, the kind of sinking you wouldn't notice with your eyes, but you might feel it in a doorway that begins to lean just slightly. A sidewalk that now pools water where it didn't before. The reasons are many. Some say it's groundwater extraction, the relentless pulling of water from ancient aquifers to feed orchards, cotton fields, canned cities that stretch toward desert. When water is removed faster than nature can replace it, the earth above begins to deflate, like a sponge, drying out, like lungs exhaling with no breath left to draw. But other scientists believe there is more to the story, because while some places are sinking, others strangely are rising. Mountains that seemed stable for centuries are gaining elevation, even as the valleys beside them collapse. And the question remains, why? One theory lies beneath the Sierra Nevada. Here, deep in the earth, there was once a chunk of thick, dense lithosphere, a piece of the Earth's outer shell that acted like an anchor dot. It held the crust in place, weighed it down. But at some point, that piece broke off, like a massive stone. Letting go from the hull of a ship, it sank into the mantle below, and without that weight, the crust above began to float. The result, Sierra Nevada rose, not all at once, not in a way you could feel, but slowly, gracefully, as if the mountain range had taken in a deep, invisible breath. And in the places nearby where no such uplift happened, the opposite began. Without pressure to resist, the ground settled more easily. It gave way to droughts, to gravity, to the memory of ancient seabeds. The result is a strange, undulating landscape, a patchwork of uplift and depression, each part responding to a different story buried beneath it. Some places rise because their burdens were released. Others sink because their foundations are thirsty, and the surface, always the storyteller of geology, records each gesture in soil and slope. But what if the ground moves for reasons even older? What if it's not just water and stone, but warmth? Scientists who studied geothermal gradients, the rate at which Earth heats up as you go deeper, have begun to notice anomalies beneath California's crust. Warm patches, rising plumes, zones where rock is being heated unevenly from below. And as it heats, it swells. Heat makes space. It pushes rock outward. Gently, patiently, like bread dough in the oven. The earth, too, can rise from inner warmth. And when the heat shifts, so does the land above it. In the Owens Valley, once home to a great glacial lake, you can stand in silence and see the bones of an ancient shoreline. It curls along the edge of the mountains, like a forgotten necklace. But that line is no longer even. It tilts, because the land has tilted. Mountains have lifted. Valleys have stretched. And even though your eyes may not catch it, the GPS can. It measures uplifts of millimeters per year. In a century, it becomes centimeters. In 1,000 years, meters, and all of it, the slow ballet of the land takes place as people walk their dogs, build their homes, plant their vineyards, unaware they're dancing on a stage that is still shifting beneath them. This is not a cause for alarm. It's a reminder that Earth is not still. That stability is an illusion offered by short lifespans, that beneath the pavement and parks, beneath the footings of your favorite cafe, there is a history of movement, still unfolding in real time. But there is no rush. The Earth never hurries. And so you rest, you breathe, you sit with the knowledge that even now, the ground is learning how to rise and fall again. If you stood still long enough, you could map the motion of the mountain, not in seconds, but in seasons, not in steps, but in silences. The uplift might be imperceptible, a fraction of an inch in a year, but it accumulates, just as the falling ground accumulates, until roads need to be repaved, till pipes bend slightly off course, until a tree tilts its roots, unsure of where down has gone. This is Earth's language, not sudden, but sure. It is tempting to imagine the Earth as solid, dependable, but in truth, it is like a body. It breathes, it expands and contracts, cued, responds to pressure, to warmth, to thirst. And in California, the crust speaks in shallow breaths, some held in, some RELEASEDA. Vineyard may rise while its neighbor sags. A mountain may lean forward a little more each decade, not enough to frighten, just enough to remind. You live on a planet that remembers what it was before you walked on it, and it will remember long after. So tonight, the sky above stretches, quiet over cities and hills. Know this, the ground below is not sleeping. It is dreaming of fire, of water, of weight, of lift. It dreams of continents that once kissed, of oceans that came and went, of ice that pressed down so hard the land still hasn't recovered. And you are the brief breath above that dreaming. Stone. Float gently on it. Let it hold you and rest, because tomorrow the Earth will still be learning how to breathe. High above the clouds, where air turns thin and silent, satellites drift in their eternal orbits. Not loud machines, not blinking beacons, but quiet watches circling Earth with lenses that never blink and signals that never sleep. They don't feel earthquakes, they don't hear rumblings, but they notice things, subtle things. The slight lean of a hill, the measured tilt of a sidewalk, a bridge's sigh, a field's gentle bow. This is not the work of eyes, but of patience, of measurement. In California, where mountains loom like old centuries and valleys stretch like deep, long exhales, a quiet conversation is always unfolding beneath the soil. The conversation is between rock and pressure, between fault lines and friction, and above it all, listening from the stars. GPS satellites trace every twitch. You wouldn't think the Earth moves when the day feels still. You walk along a street in San Luis Obispo. You sip coffee in Los Angeles. You sit beneath a tree in Riverside. Nothing seems to stir. But the truth lies not in your senses, but in the data of the thousands of tiny signals received every second from dozens of satellites orbiting overhead. These signals touch down on Earth at precise GPS stations, small, unassuming instruments, bolted into rock or steel, spread quietly across California like forgotten chess pieces. They look like nothing. No big towers, no spinning dishes, metal pins and antennae fixed to bedrock, sending whispers skyward. But each of them marks a point in space so carefully, so relentlessly, that even the Earth's slow breathing, cannot go unnoticed. Some GPS stations are installed on the crust of remote deserts where no footsteps echo. Others live on rooftops, above offices and schools, blinking silently in the California sun. They do not watch like cameras. They do not record voices. They do something stranger. They listen to the planet's stillness and record its subtle betrayals. A mountain leans half a millimeter in a year. A valley floor lowers by 3. A cliff face, long thought still, slides a fraction of an inch westward, so slowly that even time takes note, and all of it is captured every week. Geophysicists gather the signals like breadcrumbs. They line them up, and they cross-reference them. They compare this Monday's whisper with last year's murmur. And in the middle of it all, patterns emerge, not fast, not flashy, but persistent. A language of pressure, of compression, slow tectonic thought. These GPS signals have shown us that the ground is always rehearsing something. In the Owens Valley, the earth swells. In Humboldt, it flexes. In the San Gabriel Mountains, it tilts in ways it never admitted to before. But this isn't panic. This isn't alarm. This is understanding. One particular station, let's call it P301Es, bolted deep into the Sierra Nevada granite. It has recorded the rock shifting eastward at just over 12 millimeters per year. Okay, that's less than the width of your pinky nail. Okay, but it tells a story of how the Pacific plate grinds against the North American plate, a story of ancient drift, still unfolding under our homes and highways. Sometimes these changes accelerate. Okay, a drought lifts weight off the land, and the Sierra Nevada bobs upward, relieved of water. The GPS catches it. An unusually wet winter presses snow onto the same mountains, and they sag again under the burden. The GPS catches that. When Mexico's 2017 earthquake struck over 1,500 miles away, the ripples were felt not in footsteps, but in data. A tilt, a nod, barely perceptible gesture in the rocks of Southern California. It's like someone stirring in their sleep. And again, the GPS caught it. What's even more gentle and more haunting is what happens when the ground seems still, but isn't, in certain places. Particularly along creeping faults. The earth moves without earthquakes. It slips, quietly, slowly. These seismic slips are invisible to the human eye and too smooth to trigger alarms. But they still stretch the land. They still shift homes by fractions. They still leave clues, and the GPS systems, patient as ever. Notice, imagine this, a barn in the Central Valley that's been standing for 80 years. No one's touched its foundation. But the GPS on its roof tells a strange story. Each year, the barn is migrating, just a whisper of motion eastward, year after year. Its journey is silent, but it's real. And over decades, it adds up. Not enough to scare, just enough to remind us that Earth's lullabies include drift. In urban centers, GPS also listens for strain, the buildup of stress for a major quake. The ground sometimes behaves like a wound wrapping tighter. Compression shows up in the data. Not always, not reliably, but sometimes enough to raise a curious brow among scientists. These systems aren't just for earthquakes. They help with landslides, too. In the Santa Cruz Mountains, GPS arrays detect subtle slumping where gravity and geology conspire to send entire hillsides downward over years, not hours. Not with screams, but with size. GPS catches it, tracks it, helps communities plan, shift, adapt. There's a kind of beauty in this quiet surveillance. It is not invasive. It does not profile or predict humans. It respects distance, simply listens to stone. And from that listening, patterns of vulnerability emerge in Los Angeles. New modeling uses GPS data to visualize how different neighborhoods might respond to quake energy, which blocks my twist. which highways may buckle. Zones, buried under decades of forgetfulness, sit directly atop tired faults. The maps produced aren't terrifying. They're sobering. They're gentle reminders that stillness isn't always safety. Even more inspiring, the real-time nature of some systems. In the past, scientists had to wait weeks to analyze shifts. Now, in many places, GPS data is fed into live models. A tremor felt in one station can alert others in milliseconds. It's not prediction, but it is preparation. And preparation in California is its own kind of peace. And so, satellites continue to drift overhead. They do not blink. They do not speak. They only send their signals timed to the billionth of a second to small instruments below. Those instruments listen. They wait. They trace trembles not with alarm, but with precision. They chart the slow choreography of continents. They study the earth, not in screams, but in murmurs. And somewhere beneath it all, you sleep, on land that breathes, in cities that shift. But above you, the silent guardians continue their watch-marking. Each movement, no matter how gentle, with quiet, mathematical care. Because even the earth's size deserves to be remembered. They are not felt. They are not feared. And yet, they are there in the deepest hours of the night. When the sky stretches heavy with sleep and the stars blink with indifference, the earth beneath California sometimes trembles ever so slightly. But no chandelier swings, no glass rattles, no dog barks in panic. Nothing stirs except the sensors. This is the realm of phantom tremors, silent events, invisible earthquakes, movements so small, so slow, so strange. They bypass every instinct in the human body. But the earth does not move without meaning. In laboratories beneath the quiet hum of universities, and on laptops perched near geothermal fields, researchers parse this strange dance of data. They call it non-volcanic tremor, a humble term. A term that does not raise eyebrows or alarms. But to geologists, it's a whisper worth chasing. Unlike earthquakes, which scream and shatter with sudden violence, phantom tremors murmur. They last longer, but hum at lower frequencies. A normal quake might last 10 seconds. They can go on for hours, days even. But never loud, never sharp. Just a low, continuous sigh inside the earth. First discovered in Japan, a can later observed along the San Andreas Fault and deep beneath California's coast. These tremors evade every rule. They do not shake cities. They do not break windows, but they do travel, and they do repeat. Some researchers describe them as earthquakes that never finish being born. Partial releases of pressure, as if two tectonic plates tried to slide past each other, but hesitated halfway through the thought. What causes them? Found in the subduction zones, where one massive slab of earth slowly sinks beneath another. The conditions are perfect for this type of movement. Heat, pressure, friction, water seeping in. But California doesn't have a classic subduction zone anymore. The plates here scrape side by side like tired hands rubbing past one another, and yet the tremors still happen beneath the southern end of the San Andreas Fault, under towns where palm trees sway gently in the wind. These ghost quakes flicker to life now and then, detected only by ultra-sensitive instruments buried in bedrock or listening through fiber optic cables stretched beneath soil. The signals come like gentle static, a wobble, too faint to shake dust from a shelf, but real. So what are they? Scientists think they represent deep fault movement tectonic motion at the brittle ductile boundary, a place where rock stops fracturing and starts flowing, like warm caramel sliding across invisible planes of stress. Others wonder if water's the culprit superheated, groundwater injecting itself into fault zones, lubricating ancient rock, and creating frictionless slips. like two fingers skating across oiled glass. Then there are those who listen to these tremors not with curiosity, but with caution, because tremors, you see, often come before slow slip events, and slow slip events sometimes foreshadow something larger. A slow slip is exactly what it sounds like. A section of fault that gradually slides over days or weeks, relieving stress so silently that only GPS and seismometers notice. It doesn't cause damage, but it transfers pressure elsewhere, sometimes to places that are already straining under centuries of quiet. Imagine a row of dominoes. A tremor knocks one very gently. Hey, that one leans into the next, and the next. Most don't fall, but eventually, one might. That's the question researchers whisper to themselves over cups of coffee and blinking screens. Are these tremors harmless sighs of an earth-releasing tension? Too, are they the soft footsteps before a sprint? No one knows for sure. What they do know is this. In 2014, near Parkfield, a small town that calls itself the earthquake capital of the world, a deep tremor was recorded. 4 days, it hummed beneath the region. Then, silence. 9 days later, a 6.0 magnitude quake struck near Napa. Was it a coincidence? Maybe, but maybe not. Patterns are tricky things in geology. The earth doesn't repeat itself, it rhymes. And phantom tremors might be the faintest rhyme of all. Yet even if they never lead to disaster, these strange quakes offer a gift. They reveal motion where stillness is assumed. They teach us that the crust is not a stone slab, but a living, flexing boundary. One that communicates in frequencies too deep for our bones to feel. They also expose the limits of our understanding, because, for decades, scientists thought earthquakes only came in one flavor: sudden, loud, destructive. But these phantom tremors say otherwise. They remind us that not all release is violent. Some is graceful, some is kind. And this is where California becomes a classroom. It's a land of motion that whispers its lesson slowly. Even now, deep beneath the coastal ranges and the inland valleys, the tremors continue. Every few weeks, a little flutter in the earth. No one notices. Not the joggers, not the cars, not even the birds. Okay, but the sensors do. So black box recorders buried in hillsides, the fiber optic strands humming with seismic messages. And somewhere, a researcher pauses, leans forward, watches the graph bend like a sigh, and wonders, what are you trying to say? Because the earth, for all its ancient silence, does not move without reason. Its deepest messages are not warnings. They are conversations, long ones, slow ones, written in frequencies we are just beginning to read. And so, you sleep tonight above a land that breathes quietly. You do not feel the shift, but is there a phantom tremor, a sigh in the soil, a reminder that even stillness is a kind of movement, and it is never alone. In California's summer heat, when the air wavers above the roads and the hills turn gold like old parchment, there are moments when something vanishes. A lake that once shimmered, now a basin of cracked silence. A stream that once sang, now a path of dust. And a question lingers in the stillness. Where did the water go? The answer, oddly, is not always the sky. Some of it, yes, escapes upward, evaporated into invisible trails that drift and disappear. But in certain corners of California, especially where the earth wears scars of volcanic past or tectonic tension, the water doesn't rise, it sinks. It falls into the ground, slipping past the roots of vineyards and the clay beneath almond orchards. It weaves through gravel beds and fractured shale, following old faults like memory. And then, somewhere unseen, it vanishes entirely. This is not a trick of drought. It is not carelessness or thirst. It is the earth, drinking beneath parts of the Central Valley, near Coalinga and Lost Hills. Farmers once watched as entire irrigation reservoirs drained faster than they could be refilled. No rain had come, no pipes had burst, but the water was gone, and deep down, the crust had shifted. Geologists call these regions subsidence zones, places where groundwater extraction has left the underground aquifers gasping. Imagine a sponge full of water. Now squeeze it. Space once held by liquid collapses. But there is another layer beneath this story, one quieter, stranger. In regions marked by fault lines or ancient volcanoes, the rock is broken, fractured, porous in places that shouldn't be porous. These are the zones where the earth itself becomes a sieve, a sponge with forgotten tunnels. Here, when water enters, it does not return at first, it simply disappears from view. Shallow streams begin to run dry just a few miles downstream. A lake develops a crack and drains overnight like a pooled bathtub plug. Sinkholes yawn open without warning, swallowing roads and fences with quiet indifference. And still, the sky remains clear. The rivers upstream are full, but beneath the surface, the water is being drawn inward. Drawn by what? Some scientists blame lava tubes, hollow remnants of ancient volcanic flows that form secret passageways beneath the crust. These tubes, still intact thousands of years later, create an underground landscape of hidden corridors. Others point to fault-connected aquifers, deep, pressurized chambers where migrating water disappears into cracks and crevices opened by tectonic flexing. These aquifers don't just store water, they move it. And then there is the most mysterious possibility of all, deep crustal absorption at certain depths. The rock changes. It becomes less brittle, more ductile. It bends instead of breaks, and under specific pressures and temperatures. These lower layers of rock can absorb water not in puddles, but molecule by molecule within their very structure. Scientists call it serpentinization, slow chemical reaction where water meets hot olivine-rich rock and transforms it, turning it into a new mineral called serpentine. This process pulls water from the surface deep into the planet's mantle, locking it away in stone. It's not fast. It's not loud. Quite over millennia, this quiet swallowing reshapes mountains in California with its jigsaw of faults and volcanic scars. It's a perfect landscape for such vanishing acts. In Northern California's Shasta region, hikers have long told stories of strange disappearances, small lakes that refill one year and vanish the next. In the Sierra foothills, old mining shafts sometimes flood in spring and are bone dry by July, with no trace of where the water escaped. There is no villain here, no pipeline stealing the flow, only the earth, shifting subtly and drinking deeply. This behavior isn't new. Long before cities and vineyards, long before roads and railways, indigenous communities noticed these strange water patterns. They spoke of spirits in the ground, of sacred hollows where the earth took offerings and never gave them back. In many tribal languages, the names for such places translate loosely to where the land is thirsty or a valley of the disappearing spring. Even now, modern science does not fully understand these disappearing waters. We drill wells, we map aquifers, we watch water levels with satellites, but there are places where sensors fall silent, where the data shrugs, where a pond simply empties in. The maps can't explain why, and maybe it's okay, because not everything must be measured to be real. Not everything that vanishes is lost in the southern San Joaquin Valley, a Talalite. Data reveals something else. The ground is sinking. Entire towns, like Corcoran and Mendota, have subsided by over 20 feet in the past century. It doesn't happen overnight. It's a slow-motion collapse measured in inches per year, sometimes faster in droughts. And it's not from earthquakes. It's not from mining. It's from water, or rather, from the lack of it. When aquifers are drained too fast, the land above collapses into the empty space. The crust buckles, folds, and bows inward. It's as if the earth exhales after holding its breath for too long. And this sinking isn't just a visual curiosity. It damages canals, cracks, roads, spins, railways, tilts, foundations. And once the land compresses like this, those underground chambers can't simply refill with the next good rain. The sponge has lost its spring. The damage is permanent. The earth in these places has changed its shape. And what of the water that remains? It flows deeper. It moves into unknown places, past the reach of most wells and sensors. It collects in ancient rock, locked between grains, pressurized by stone. Some of it will stay down there for 100 years, some for 1,000, and some may rise again centuries from now as a hot spring, a geyser, or a faint wisp of steam on a cold morning, because the earth does not forget what it drinks tonight. Above these thirsty valleys, you sleep. You may not feel the silence beneath you. You may not know where the stream has gone, but the ground beneath your pillow is not still. It breathes. It drinks. It remembers. Somewhere deep below, a drop of water begins a new life, not as a cloud, not as a flood, but as a whisper in stone. And the earth holds it, quietly, quietly. You cannot feel it as you walk. The ground does not steam. The pavement does not burn. But deep beneath the almond groves, the vineyards, the sidewalks of San Jose and Fresno, there is heat. And it is rising, not the kind that scorches, not the kind that cracks open the crust, but a slow breath like warmth, pressing upward through the pores of the earth. It has always been there, long before California had a name. 4 valleys were carved and foothills wore trails. This heat pulsed gently under the crust, a leftover hum from the earth's molten beginnings. And now, in quiet places, it rises again, not in flame or ash, but in warm gas, in quiet shifts, in surface temperatures, just a little too high for the season. In the eastern stretch of California, where the land starts to wrinkle into the Sierra Nevada, scientists have found thermal anomalies, not hot spots, nothing dramatic, but places where the soil reads warmer than expected, where groundwater, meant to be icy and still, comes up tepid and restless. These are not accidents. They are not errors in measurement. They're signals, soft pulses from the planet's slow heart. You see, the earth does not cool in silence. Beneath the brittle crust lies the asthenosphere region of partially molten rock that flows, not like water, but like syrup, warmed just enough to move. This layer shifts tectonic plates like icebergs on a thick sea of heat, and sometimes, through faults and fractures, this warmth climbs toward the surface, not all at once, but in quiet exhalations, like breath through sleeping lips, in places like Long Valley Caldera, not far from Mammoth Lakes. This heat makes itself known in the form of soil gas emissions, tar, carbon dioxide, methane, sulfur. They drift upward from deep chambers where magma lurks like memory. Tourists walk the trails above, unaware, but rangers and geologists monitor the trees because, in some places, the trees die standing up. Their roots, suffocated by sea-rich soil, cannot breathe. Their leaves wither, their bark cracks, and they remain like statues, markers of where the earth is quietly exhaling. The air is not hot, but it is alive. If you could stand still in these places, truly still, might feel it, not on your skin, but in the subtle way that insects avoid a certain patch, that birds don't nest near certain rocks. Heat in these landscapes does not roar. It seeps, it listens, it looks for paths, and when it finds one through volcanic vents, through geothermal springs, it leaves a trace dot down in the geysers. North of San Francisco, this heat has become a resource. Steam trapped in rock is tapped by power plants. Pipes lead deep into the earth, drawing up invisible energy to power homes, lights, lives, But even there, the heat is careful. It does not explode. It whispers. And engineers must listen with reverence, because if the pressure is changed too suddenly, if water is extracted too greedily, the earth beneath the turbines trembles, not violently, not yet, but enough to remind us that heat, however quiet as power, this rising warmth affects more than machines. It alters water chemistry. It creates tiny ecosystems, microbial worlds that thrive where no sunlight reaches. It opens fractures wider, softens rock, and sometimes, without warning, it shifts the schedule of the land. A hillside collapses where the rock became too weak. A hot spring grows hotter. A fault that was once quiet begins to tick again. No disaster, no headlines, just a gentle note from the belly of the world. I am still warm to the casual eye. These changes are invisible, but satellites see them. Thermal sensors on board instruments like NASA's Aster take subtle surface temperature variations, even just a few degrees, even in the middle of the night. And over time, a pattern emerges. A slow swelling here, a heat bloom there, and always beneath it, all a consistency, like a low hum in a quiet room. But why now? Why is California's underground warming? One answer lies in the changing balance above. Climate change warms the surface, yes, but it also alters pressure, ice melt, water weight. As snowpacks shrink and groundwater is drawn deeper, the load on the crust changes, and when pressure lifts, the crust size. In some places, this releases stored heat long trapped by stone. In others, it invites deeper magma to edge closer to the surface, not to erupt, but to feel, to sense the thinner skin above too. Imagine the possibility of return. Scientists call this decompression, melting. It's a slow, silent process where rock, given just enough freedom, begins to soften too, melt ever so slightly, not into rivers of lava, but into pockets of possibility. Magma chambers swell like lungs below the Sierra Nevada, not full, not violent, but waiting, listening, rising in inches as the earth rearranges itself. And yet, its warmth also brings life. In certain springs, its bacteria flourish, tiny, heat-loving organisms called thermophiles. They glow under microscopes in strange reds and greens. They feast on minerals and gases. They have no need for sun, and in their DNA may lie clues to the origins of life itself, because Earth was once this hot, once this hostile, and somehow once this generous. So tonight, as you sleep in your room, curtains drawn, cool air humming, phone on the nightstand, Earth spinning softly beneath, know that something warm is climbing toward you. It is not danger. It is not disaster. It is the long, slow breath of a planet remembering its youth. It is the whisper of fire beneath the quilt of cities and silence. It is heat, gentle and ancient, reminding you that beneath all stillness there is movement. You hear the word supervolcano and you think of fire, ash, panic, apocalypse. But beneath the soft hills of California's inland valleys, beneath the long shadows of the Sierra, beneath grazing cattle and weekend cabins, the story is slower, older, and quieter, because supervolcanoes don't breathe like normal volcanoes. They wait for centuries, for millennia. They forget nothing, but they speak only in the language of pressure. To understand them, you must let go of how we imagine eruptions, not cones, not mountaintops with craters, vast, sunken scars in the earth, not carved by glaciers, not worn by time, but collapsed by force. Because when a supervolcano breathes out, it does so with a violence so complete that the ground cannot stay up. It empties its belly, then falls inward, and what's left behind is a quiet place, a peaceful basin, a meadow, maybe, or a sleepy lake. You wouldn't even know what it once was, unless you were listening to the rock in California, One of these places waits beneath the land. The Long Valley Caldera. It doesn't rise into the sky like Mount Shasta or Mount Lasan. It lies low. A depression in the earth, 20 miles wide, ringed with jagged ridges and volcanic ghosts. To drive past it, you'd see trees, trails, birds wheeling in the air. You'd feel calm, and yet something stirs beneath this caldera. Last erupted 760,000 years ago. It covered hundreds of miles in ash. Its breath reached from the Sierra to the Midwest. The eruption was 2,000 times larger than Mount St. Helens. And then it went quiet. The kind of quiet that lasts longer than civilizations. Long enough for deer paths to grow into forests. Long enough for us to forget. But the earth does not forget. Geologists monitor Long Valley with the patience of monks. They do not expect fire, They do not sound alarms, but they measure, because the ground still swells. Not fast, just millimeters a year. Just enough to know that heat and magma and pressure still live down below. There are no explosions, but the earth sighs, and the sighs are recorded in the 1980s. Something shifted. Seismic swarms, a series of hundreds of tiny earthquakes, began to ripple through the caldera floor, some shallow, some deep, like whispers rising through the crust. Then the ground rose over the span of a few years. The surface lifted by more than 10 inches. The scientists called it resurgent damming. The land was swelling, as if the old breath beneath it had stirred again. No one evacuated. No disaster followed. But from that decade onward, Long Valley was reclassified. No longer forgotten. It's no longer extinct. Simply waiting, and it's not. The only one dot to the west, nestled in the folds of Napa and Sonoma, lies the Clear Lake volcanic field. It hasn't erupted in 11,000 years, but its underground system still cooks. In fact, it powers the geysers, the largest geothermal energy facility in the United States. Here, steam from ancient magma heats turbines. Electricity hums through miles of wires, energy pulled from silence. The volcano itself sleeps, but its body is warm, and warmth is never just background noise. Southward, another shadow lingers, the Coso volcanic field. East of the Sierra Crest, no lush vineyards, here just desert. But the land is cracked with fumaroles, laced with faults, peppered with cinder cones. Coso, too, powers a geothermal field. Coso, too, is not extinct, and though no eruption has occurred in modern history, the rock pulses with heat, and heat is a kind of memory. These volcanic systems are not like Mount Vesuvius, with fiery outbursts and roaring lava. They are deeper, wider, more ancient in their rest. They do not wake for centuries, and when they do, they rewrite the map. But until then, take simmer, and if you listen with seismographs, with gas sensors, with satellites, you can hear their breath. It is not dramatic, it is not even alarming, but it is there, a supervolcano. Eruption is not something science can predict with precision. There is no countdown, no glowing crack, no soon. Instead, scientists watch for patterns, changes in gas emissions, like increases in sulfur dioxide or carbon dioxide, new hydrothermal activity, like boiling springs where there once was cool water, micro-earthquakes that migrate, forming trails through the crust, and, above all, uplift, the swelling of land. So slow a human eye would never notice, but clear as day in satellite data. And yet, in all this watching, there is no certainty, only probability, only models, only educated patience, because the earth is old, its timelines do not bend to our urgency. Long Valley might sleep for another million years, or it might sigh deeper next decade. Science does not claim to know, it only listens, hoping to understand the lullaby of rock and fire. If a supervolcano were to awaken in California, truly awaken, it would not just affect the West. The ash could circle the globe. Skies would dim. temperatures would drop, not forever, but long enough to change the rhythm of harvests, to pause the breath of cities. But this is not fear. It is only awareness, because tonight there is no ash, no fire, only heat, only magma, shifting like a warm sea beneath your bed, only ancient silence, pressing gently against stone. So sleep gently above these shadows. Let the mountains hold your weight. Let the rock remember, because the earth beneath, California, is not asleep. A key, but it is not angry. It is only breathing quietly, as it has for thousands of years. There are places where you expect the ground to break, along a fault line drawn bold across a map, beneath a city known for tremors, beside a volcano with a scarred crown. But then, there are places where the earth splits softly, without reason, without warning, without the drama of prediction. A quiet pasture, a cracked road in the middle of nowhere, a single fence post that leans more each year. No alarms, no headlines, just a whisper of pressure escaping at the edge of understanding. In California's Central Valley, the land is flat, open, fertile. It stretches in golden grids, lined with almond orchards and cotton rows, traced by irrigation canals and tractor dust. But sometimes, surface does something strange. It fractures, not from a quake, not from drought alone, but from a slow rearrangement beneath. These fractures don't roar, they yawn. Long, lazy cracks them, wide enough to lose a shoe, stretch across fields without shaking the earth. They follow no textbook fault. They ignore the rules of seismology. They appear in patterns we barely grasp. They are called ground fissures. But the name doesn't explain them, because how do you name the earth when it decides to change shape? Geologists walk these lines with care, not because they're dangerous, but because they are humbling. Some are caused by land subsidence, where groundwater has been pulled too greedily from deep wells. The earth above collapses slightly, then more, until the surface adjusts with the stretch and tear. It's not violent. It's not sudden. It's more like exhaling through the soil. But not all of these cracks come from thirst. Some come from tectonic creep, the silent, continuous motion of faults that never quite lock up, never quite release. Instead of a quake, the land moves by fractions of an inch each year, like a glacier of stone, invisible to the eye, but inevitable over time. And when the surface can't stretch any further, it cracks, not loudly, not once, but quietly, and again in the hills of Parkfield, California, known as the earthquake capital of the world. This kind of motion is carefully watched. The San Andreas Fault runs directly through the town. It split roads, shifted barns, bent fences over decades, but not with chaos, with rhythm. Every few years, the earth moves a little. People there expect it. They study it. They live with it. Even the water pipes are built with flexible joints, ready to bend, to twist, to let the earth pass through without shattering. But in other parts of the state, the patterns are less kind. In Imperial County, down near the Mexican border, cracks appear where no one expects them, not on faults, not near volcanoes, but in salt flats, farm plots, desert scrub. They split irrigation canals. They tilt telephone poles. Sometimes they fill with wind-blown dust and vanish again. Other times they deepen year by year, a reminder that something underground is always at work. Engineers try to map these lines, to overlay them on satellite images, to measure them with LiDAR and GPS. But the earth doesn't always agree with maps. Cracks appear parallel to known faults, but a few hundred feet off, they branch in strange angles, as if drawn by a tired hand. They vanish beneath highways, only to re-emerge in quiet backyards. What causes them? Pressure, shear, tilt, change, but above all, time, because time pulls at everything, and the earth, for all its weight, is not immune to the long, gentle tug of gravity, heat, and memory. Some of these cracks are ancient, reawakening after centuries. asleep. Others are newborn, fresh wounds in a landscape shaped by water and thirst. Some hint at something deeper, at magma flows far below, at the slow migration of geologic tension. Others are the result of human hands drawing too much from the land without leaving time to recover. In a field near Mendota, a farmer once reported a deep groove slicing through his orchard. It hadn't been there a month before. By the end of the season, the trees leaned in two directions, its roots exposed to dry wind. No earthquake had been felt. No news had reported it. But the earth had moved, and the land, like tired skin, it split open under unseen stress. There is something deeply human about trying to measure cracks. We want to know how wide, how deep, how long. We want to predict their growth, to chart their path, to understand them. But sometimes the earth doesn't offer that. Sometimes a fissure is not a prophecy, it's just a scar, not a warning, just a sigh. And yet, learn from them. We learn to watch more carefully, to listen to the ground in new ways, to use INSAR satellites that can detect changes in elevation, small as a centimeter, to fly drones with thermal cameras that see heat rising from cracks before they grow. 2. Study microseismic patterns, and wonder what fault lines we haven't named yet. Because if the earth is drawing new lines, it's doing so with an old pen. And maybe those lines aren't meant for panic. Maybe they're meant for pause, to remind us that the land we stand on is not still, that a road is only flat until the ground remembers something deeper, that a city, for all its foundations, is built on breath. And so tonight, if you walk a field and see a crack under your feet, don't fear it, just notice it. Notice its direction, its depth, its silence, because even the smallest fracture can carry the weight of a continent's past. And even the tiniest shift can be a story the earth has been waiting to tell. The earth is made of pieces, not whole, not still, but drifting. We call them tectonic plates, massive slabs of crust and upper mantle, floating on a sea of slow-moving rock, so vast and ancient they make continents look like passengers. And under California, the dance of these plates never ends to the west, the Pacific Plate, sliding north like a silent train on tracks too wide to see. To the east, the North American Plate, a continent unto itself, pushing westward with the deep, imperceptible strength of thousands of miles of land between them, a jagged boundary, a line not drawn but felt, the San Andreas Fault, a fault not just of geography, but of time, memory, and motion. But it's not just one fault. California is laced with them, from the creeping Hayward Fault to the hidden menace of the Garlock, from the vertical tiers of the Elsinore to the subtle shears of the Calaveras. This land doesn't just sit. It slides, it stretches, it flexes like old leather, scarred by every movement it survived. Imagine two books pressed together, slowly rubbed side to side. Friction builds, edges catch. Eventually, a corner slips free. That's how the plates move, but at their edges, and sometimes in between. The land doesn't stay passive. It stretches, not like rubber, but like stone, remembering how to bend. This lateral slip causes strange things. A fence built straight becomes a curve. A railroad track swells into a crooked S. A vineyard row planted in neat lines now tilts with drunken grace. To live here is to live in gentle contradiction, on land that seems solid, but remembers how to drift. In the Carrizo Plain, a quiet landscape of golden grasses and dry hills, you can see the stretch between plates. There, the San Andreas Fault reveals itself openly. A creek diverts abruptly, shifted by 300 feet over thousands of years. A hillside, once continuous, is now displaced, torn not by one earthquake, but by a series of silent agreements between moving ground. This is not destruction, it's negotiation. But in other places, conversation between plates becomes louder. Sometimes it erupts into earthquakes, shaking, rolling, impossible to ignore, but most of the time, it is quiet. This movement, this seismic creep, happens without tremor, like a door slowly opening, but without a sound. It's measured not in seconds, but in millimeters per year. Still, over a lifetime, it leaves fingerprints everywhere. There are towns that have been built, and rebuilt on top of these creeping stretches. Hollister, California, a small city that wears its fault lines like wrinkles, is home to sidewalks that split again and again. No disaster, no panic, just concrete, gently torn apart by a world that refuses to stay still. And so the city patches, pours, and shrugs, as if to say, "We know, we're listening." This creeping motion is both blessing and curse. It releases energy gradually, possibly preventing the buildup that causes big quakes, but it also hides deeper stresses, locked faults that stay silent for decades before they suddenly speak. In this way, the stretch between plates is both sigh and scream, depending on when you choose to listen. Far below the surface, the mantle flows like warm stone syrup. Its slow churn pulls at the plates above, nudging them like ancient gears. This flow creates zones of tension. Not all motion is horizontal. Some parts of California are being pulled apart. The Eastern California shear zone is one such area. There, deep under the Mojave, the crust itself is tearing gently, not because of fault lines, but because the very skin of the continent is being stretched thin. This stretching forms what geologists call a rift zone, a place where someday, in millions of years, new ocean might open, a place where the earth dreams of creating new boundaries, but for now, simply pulls. In the surface above the deserts, highways, mountains shift with it, almost imperceptibly, but forever. You may never feel this stretch beneath your feet. You may walk across it every day, unaware, but GPS knows. Modern satellites, hovering far above, track movements as small as a fingernail's width. They see the state of California being stretched diagonally northwest to southeast by fractions of an inch each year. But, like all long stories, those fractions add up. In 500,000 years, Los Angeles and San Francisco will sit side by side, not because one has moved to the other, but because the ground beneath them insisted on it. And in 10 million years, they may no longer be part of the same continent at all. This is how the Earth thinks, in centuries, in epochs, in motions too slow for memory, but too steady to stop. The stretch between plates is not something we can stop, but we can learn from it. We can build smarter with foundations that shift with the land, not against it. We can plan for slow disaster, the kind that takes a generation to notice, but only a moment to regret. And more than anything, we can learn to listen to the places where the earth doesn't roar, but murmurs. So if tonight you lie in bed somewhere in California, the ground feels still beneath you, remember, it is not, it is stretching, breathing, reaching for a future you'll never live to see. But that's not a threat, it's a story, and you, for now, are resting on the chapter between shifts, beneath your feet, beneath the bones of California's crust, beneath the roads and farms and quiet bedroom ceilings. There is something that never cools, never sleeps, never stops remembering what it is. Magma, molten rock, not lava is what erupts, what spills. But magma is what waits. It lives under the surface, in chambers and fractures, like lungs beneath ribs. Invisible but necessary, pressurized but patient. It does not rise because it wants to destroy. It rises because that is its nature, to move, to warm, to remind the world above that the world below is not empty. In the central depths of California, particularly near Long Valley and Mammoth, the magma has not forgotten its shape. It has not gone still. It swells, not like a balloon, but like a sleeping chest drawing in air, slowly, deeply. almost imperceptibly. Geologists call this uplift, a term that sounds gentle, like encouragement. But in reality, it means the land is shifting upward, inches at first, then feet, all because magma is on the move. There is no eruption, no ash, no fire, just movement, pressure, volume, or there should be none. Expansion that creates tension, like a note held too long by a distant cello. Too low to hear, but felt somewhere near your spine. The earth is tuning itself again, very slowly, very carefully. Scientists place GPS instruments across the land, pin them to granite, calibrate them against the stars. They track how the ground lifts, how it subtly exhales. The movement tells a story that magma is not randomly wandering. It collects pools in chambers shaped like bowls, layers, ovals, long curling fingers of hot rock that seek weakness in the ancient crust. Not every collection becomes an eruption. In fact, almost none do. Most simply, linger, hot, alive, just. Beneath that, the magma under California behaves like memory. It never forgets its paths, the tubes and tunnels carved by eruptions long ago. It follows old fault lines like grooves on vinyl. It's playing a tune the surface hasn't heard in millennia. Sometimes it pulses. Sometimes it stalls. There are earthquakes tied not to tectonic plates, but to magma moving through cracks like a slow breath between stones. These are called volcanic quakes, and they don't roar. They thrum. They are the sound of earth adjusting its insides. In the Coso volcanic field, east of the Sierra Nevada, a magma body sits deep below, feeding hot springs and geothermal energy plants. The area above it feels restless. Steam rises, rocks fracture, not violently, but like joints stretching after centuries of stillness, and deeper, still deeper than most wells dare to go. A slow plume of magma pushes upward like warm ink inside thick parchment. It has no deadline. It simply continues. In some places, magma forms domes, slow bulges that reshape the ground. The resurgent dome in Long Valley Caldera is one such place. It rises quietly, lifting the land above like dough left too long in the sun. Visitors don't notice. The grass still grows. The air still smells like pine. Then, but if you compare satellite images year over year, you'll see it, a gentle arch, forming in the landscape. That's what magma is doing now. It's not exploding, it's just remembering its strength. Heat maps reveal strange, glowing signatures beneath the earth. Bright clusters, orange and red, where the magma glows too close to the surface. These are not warnings. They are invitations to understand. The earth is not hiding from us. It is simply older than our definitions of danger. We want certainty. It offers process, and the process is patient. Beneath Clear Lake, north of Napa Valley, magma warms the bedrock. The water above steams. The soil carries a strange warmth. People sip wine in the vineyards nearby, unaware that their vines grow from land whispered into fertility by ancient fire below. That's the strange gift of magma. It destroys, but also nourishes. After eruption, it leaves minerals, rich soil, thermal energy, stories written in basalt and ashdot. It is a cycle not of cruelty, but of repetition. What magma is doing now, in many places, is simply waiting, but not idly. It listens for fractures. It tests the resilience of rock. It follows water down into the crust, boils it into steam, and pushes it gently, testing the ceiling of the world. The pressure builds slowly, like emotion held in silence. And then, one day, maybe it speaks, but not today. Today, the magma continues its patient rehearsal. We often imagine magma as a villain, molten, red, chasing down villagers in movies. But in truth, it is more like the earth's blood. It's not evil, just vital. It circulates slowly, rises only when it must. It chooses the weakest path, never brute force. Only flow, and what's most remarkable is that we can sense it now. Our instruments have grown delicate enough to hear magma whispering in its sleep. That's what the tremors, the heat, the domes, and gas emissions mean. They're not threats, they're murmurs from below. You may never feel this magma, never see it, but in some places you might smell the sulfur, see the steam. Notice a tree leaning slightly where the land is lifted, and in those quiet signs, you'll find the message that the earth is not dead, it is dreaming. And beneath your world, something ancient is still stretching its arms, not to destroy, but to remember, to rise very slowly toward light it will never see. Sometimes the earth does not crack open. Times it simply exhales, and the breath that escapes is not wind or weather, but gas, invisible, ancient, unfolding softly from places no one remembers digging, in vineyards, in valleys, between the roots of olive trees and forgotten roadways, California's crust sighs, and in that sigh comes a strange perfume, the quiet scent of deep time, sulfur, carbon dioxide, methane, radon. Each gas tells a different story. Each one rises not from surface rot or factory exhaust, but from something deeper, something elemental. There are places where you might crouch near a fissure in the rock and smell eggs, sour and faint, or walk a trail where the grass wilts in peculiar patterns. Not because of drought, but because the soil beneath it is breathing something unfriendly to the unaware. It smells like nature. To a geologist, it smells like warning. In California's geothermal zones, like the geysers north of San Francisco, steam rises not from boiling kettles, but from Earth's own fever. Their power plants tap into the crust's exhalations. They collect the steam, turn it into electricity. It hums into homes as a quiet miracle. But even outside the industrial fences, you can walk among rocks, warm to the touch, and feel gas on your face like the whisper of something forgotten. Carbon dioxide is the quietest. It has no smell, no color, no cry. It pools in low places, heavier than air, and lingers there, like a memory no one speaks of. In places like Mammoth Mountain, small animals sometimes perish near tree stumps, not from predators, but from breathless air. Coat seeps from the soil, coats the ground like glass you didn't know was there. And the trees die too, not all at once, but slowly. Needles yellowing, branches curling, roots starving in gas-choked soil. The forest becomes a slow elegy for something moving just beneath. Then there's radon, the shy isotope. You cannot see it, cannot taste it, but it moves through cracks in basements and cellars, and if inhaled too long, it begins to write itself into your cells. It's not a message, exactly, just a presence, a signature from deep uranium decay, from bedrock that forgot how to be still. In California, as in many seismically active regions, radon levels spike before quakes, not because the earth is trying to warn us, but because it stretches, cracks, leaks, and what leaks first is not sound or movement, but gas. Sulfur, on the other hand, is bold, denounces itself, sent like boiled metal and ghost fires. It bubbles through hot springs, hugs the edges of ancient volcanic hills. In places like Salton Buttes in Imperial Valley, you might find mud pots boiling softly in the sun, not from heat alone, but from gas pushing upward like a message in Morse. Each bubble that pops is a syllable in Earth's slow sentence. You can't read it, not fully, but you can feel the tension in your chest as the air wavers above cracked clay. It's not danger, not yet, but it's not peace either. Why does the earth do this? 'Cause beneath all our maps, our cities, our tidy fences, and road signs, the crust is thin. Only a few dozen kilometers separate us from a sea of rock that flows, melts, and reforms in a language we barely understand. And when pressure builds, when molten rock rises but doesn't reach the surface, the gases escape first. They seep through pores, follow fault lines, ride water like stowaways. They come first, before the quake, before the eruption, not to warn, just to breathe. Scientists measure these breaths with long, silent tools, instruments buried in the soil, in wells, on mountain slopes. They test the air for sulfur, for carbon, for radon. And when the levels change suddenly, they don't panic. Listen, gas is like a sigh in a sleeping body. It doesn't mean waking, but it tells you the dream is shifting. In Long Valley caldera, gas emissions have waxed and waned for decades. It's an ancient volcanic wound, a scar not healed but quieted. There, geochemists gather samples, test the ratios of helium isotopes, a kind of fingerprint that tells them how deep the gas comes from. Some ratios whisper, "This is shallow, from groundwater and limestone." Others hiss, "I am from the mantle, from somewhere older than you can measure." Those readings make people sit a little straighter in their lab chairs, because when deep gases rise, means something is stirring far below the crust. Even in the Central Valley, gas can find its way upward. In irrigation ditches, in empty fields, in forgotten corners between highways and fences, a strange bubbling might occur. Locals sometimes think it's decay, a dead animal, a septic tank leak, but it's neither. It's geology, sighing through the seams. Some gases carry heat, others carry scent, but all carry story. They are, in a way, the Earth's breath, not exhaled in anger, but in continuity. Every bubble in a hot spring, every haze above a thermal field, every dry creek bed that smells like something burning under it. These are not problems. They are reminders that beneath all stillness, beneath the crunch of gravel beneath your feet, beneath the rows of suburban houses or sleepy cow pastures, the earth has not gone still. It only exhales in ways we've forgotten how to listen to. And maybe that's what these strange gases offer us. Not just data, not just the promise of geothermal energy, not even the hint of volcanic activity, but a sense of humility that the air we breathe is touched by things we cannot see, by fires we didn't light, by processes we didn't start and cannot stop. So you walk through California, through a vineyard, past a sulfur spring, or through a forest with oddly yellow trees, and you wonder, what is the earth saying right now beneath this inch of soil? And then you realize you don't have to understand it all. You just have to know that it's still speaking, softly, invisibly, from deep, strange depths. We like to believe the earth follows patterns, that every mountain has a cause, every quake a line, every tremble a reason drawn clean on a map. But deep beneath California, beneath the almond orchards and wind farms, beneath the whisper of ocean fog rolling over dry soil, there are faults that do not follow rules. They do not behave. They do not align. They fracture sideways. They fold upward. They slip when nothing has changed. And in doing so, they remind us the earth is not a machine. It is a memory in motion. Some faults announce themselves. The San Andreas, long and proud, traces nearly 800 miles from the Salton Sea in the south to Cape Mendocino in the north. It is a celebrity of geology. It marches in a line you can trace with your finger. But others are ghosts. They curve where they should crack. They split into forks. They braid through bedrock like rivers dried long ago. The Hayward Fault, for instance. It hides in plain sight. It runs through parks, past shopping malls, under sidewalks where children play hopscotch. But the tremble it brings is never straight. It is jittery. It pulls at odd angles. It strikes not where it looks strongest, but where the crust feels weakest. And that weakness, it changes with time, like old wood remembering rot. In Southern California, there are faults that bend like hairpins. Some push upward. Others slide past one another, not north-south, not east-west, but somewhere in between, a crooked dance choreographed by heat, pressure, and past lives. These are called oblique slip faults. They do not crack like dry clay. They twist like soft bread dough stretched under a slow, invisible hand. Imagine the land as fabric-worn denim, perhaps. And now imagine that fabric being tugged, not from the corners, but from the middle, diagonally. It frays, it bunches. It doesn't rip where you expect. That is how some faults behave. Beneath Los Angeles, dozens of blind faults crisscross, unmapped for years. Not because no one looked, but because they never reached the surface. These faults do their work in silence. They hide beneath the dust and asphalt, waiting for the right pressure. The wrong time, in 1994, the North Ridge earthquake surprised the world. It didn't come from the famous San Andreas. It came from a fault no one had noticed, a hidden one, a quiet one. That quake moved the ground upward, pushing buildings not side to side, but vertically, like the earth was shrugging its shoulders. There are even places where one earthquake triggers another, not nearby, but hundreds of miles away. A ripple in one place awakens a fracture in another. Scientists call this dynamic triggering. It breaks our rules because we like to think this area is quiet, this area is safe. Why? But the earth doesn't use our zoning maps. Why? It uses memory, and in that memory, everything is connected. A tremble in Ridgecrest can unsettle a fault in Nevada. A shift in Baja can hum a vibration into Oregon. Some faults move every few hundred years. Others, every few decades. Can some move slowly, without earthquakes at all. This is called a seismic creep, a gentle, continuous slipping of the crust. No sound, no shudder, just emotion, like a sigh you didn't know you were holding. In Hollister, California, curbs tilt over time, fences warp, sidewalks split, not with force, but with patience. A fault runs beneath the town, and it creeps. Some residents call it the fault that builds nothing and breaks everything, 'cause it doesn't shake houses, but it bends them slowly out of shape. And then there are faults that suddenly appear. It's not born from plates, but from human hands. Yes, our drilling, our pumping, our fracking. Sometimes we disturb ancient scars in the crust. We inject water into deep rock, and we awaken faults that hadn't moved in thousands of years. These are called induced faults. They remind us we are not above the Earth's rules. We're simply participants in a very old conversation. And when we don't listen, the land answers louder. Some faults don't even follow themselves. They jump. They start here, then leap a few miles, and continue there. It's like writing a sentence, then lifting your pen, finishing it across the page. This happened during the 2019 Ridgecrest earthquakes. One fault snapped, then another joined in. They didn't line up neatly, They shared no clear connection on the surface, but underground, they understood each other. That's what the crust does. It communicates, not in words, but in stress, strain, and the memory of movement. Even the most well-behaved faults sometimes disobey their patterns. The San Andreas, long believed to slip in massive events every 150 years, has stretches that haven't moved in over 300, and others that release small energy every few decades. It's not broken, it's improvising. That's what Earth does best. In seismic labs, scientists run simulations, plug data into models. They try to predict the next quake, to draw maps of likely rupture. But the faults, they laugh at these efforts, not cruelly, honestly, because they know they are not rulers on a desk. They are scars on living bone, and bone remembers differently than numbers ever could. So what does it mean to live above faults that don't follow rules? It means you live on a story still being written. You build homes on a slow breath. 2. Drink coffee above a sleeping stretch of earth that might stretch in return, but not today. And maybe not tomorrow, maybe never, but maybe when no one's expecting, a sideways shiver will ripple through that misaligned seam. And a new sentence will be written into the soil. And when that happens, people will look at maps. They'll say, but this wasn't the fault. Lie. They'll point fingers at geology, at scientists, at fate. But the earth doesn't lie. It simply speaks in ways we haven't fully learned to interpret. Its grammar, its pressure, its punctuation, its pause. Sentence structure is a million years long, and some of those sentences have yet to end. It's a simple question, heavy with hope, tinged with fear. Okay, we predict what comes next. You hear it after every tremor. Okay, after every shudder in the night. Okay, after every strange vibration that leaves glasses clinking softly in the cupboard. Okay, we know. Can we forecast it like weather? Warn the cities in time. Turn sirens on before the earth speaks. The truth is softer, slower, and harder to hold. Prediction lives in the space between certainty and curiosity. And the earth, with all its wisdom, seldom offers either. Scientists have tried. For decades, they've watched the faults, measured the strain, tracked the tilt of hillsides and the micro-movements of satellite signals. They've built machines that hear things you can't. Tiny clicks in the rock, subtle shifts in magnetism, changes in groundwater levels that hint at something gathering strength below. They place seismometers in deep wells, bury fiber optic cables through deserts, install tilt meters in mountain ranges just to catch the earth blinking. But still, okay, it does not whisper its secrets easily. There are warning signs, yes, but they are inconsistent. Quake might be preceded by hundreds of small tremors, or none. The ground might bulge upward slightly, or stay still until it splits. Even animals, once believed to sense earthquakes in advance, offer more mystery than method. Some dogs bark, some birds fly off, but not always, okay, and not reliably. The earth, it seems, does not send invitations to its moments of violence. It simply arrives on its own time. And you are left interpreting the echoes. There is, however, a kind of soft prediction. Not of when, but of where. Scientists build hazard maps, showing which regions are most likely to feel the Earth's movement. California is red and orange in these maps, not because it's angry, but because it's alive, crossed with faults, full of stored tension, okay, and shaped by a past that promises more. These maps tell you, build differently here. Anchor your walls, brace your bridges, plan your escape routes, not in panic, but in patience. It is not about preventing the shake, it's about surviving it. Then there's the promise of early warning systems. They don't predict the quake, but they can warn you once it begins. When an earthquake strikes, it sends out two kinds of waves. The first, P waves, are fast but gentle. They ripple silently through the rock. The second S waves are slower but violent. K, they cause the shaking you feel. Sensors can detect those early P waves and send alerts ahead of the S waves. Sometimes, spies you a few seconds, 10, maybe 20, just enough to duck, just enough to brace, just enough to remind yourself, this is not the end. In Japan, these seconds have saved lives. In Mexico, they've stopped trains before derailment. In California, the system is young, but it listens, always. But even the best system cannot answer the real question. When will the next big one come? Geologists can guess. Say, within the next 30 years, there's a 70% chance of a major earthquake along this fault. But what does that mean to a mother kissing her child goodnight? To a commuter boarding a train? To a grandfather watching the sunset on the same porch he's known for 40 years? It means nothing and everything, because the earth does not run on calendars. Its time is folded, stretched, unconcerned with human schedules. It moves when it must. Some scientists believe the answers lie in the deep earth. They study the movement of tectonic plates, not just at the surface, but hundreds of miles down, where rocks behave like warm wax, and the planet's memory is written in pressure. They model heat. They track magma. They try to understand how tension builds, how it lingers, how it finally lets go. They speak of stress shadows, areas temporarily safe after a major quake. They speak of seismic gaps, areas overdue, silent for too long. But the Earth does not confirm or deny. It listens and moves when ready. Others look to new technologies. Some are watching the ionosphere, the upper atmosphere above the Earth, for subtle electrical changes that may accompany deep stress underground. Others study earthquake lights, rare flashes that appear before some quakes. Still unexplained, still debated, still mysterious. There is even hope in artificial intelligence, training machines to read patterns humans cannot see, to detect rhythms in the chaotic noise of the crust, to learn the Earth as if it were a language. But no model, no algorithm, no whisper of machine logic can yet say, tomorrow, here, now. And so we return, not to certainty, but to awareness, to the quiet truth that we live on a breathing world, that every step is on a shell, cracked, creased, beautiful, that safety is not guaranteed, but preparedness is, that fear can be softened with knowledge, with resilience, with the decision to listen. So, can we predict what comes next? Not exactly, not yet, but we can learn the signs. We can trace the trembles, can listen to the silence as much as the sound. We can watch the Earth not as something to conquer, but as something to understand. And in doing so, we stand not against the quake, but with it, with open eyes, can steady breath. Night falls across California. The lights of Los Angeles flicker like distant stars. Bay windows reflect quiet kitchen tables. The hum of streetlights and engines softens as a hush settles over the land. But the ground beneath, it does not sleep. It moves slowly, silently, in ways that even science cannot always hear. You live in houses built on borrowed stillness, on land that remembers a different rhythm, a slower heartbeat, a deeper breath. To sleep above fire is to trust the Earth. The crust beneath your bed is not solid. It is not forever. It floats on layers of warmth and motion, on a mantle that flows like ancient honey, faults that stretch like patient scars. Every hill you see in the daylight, every ridge and basin was shaped not by peace, but by pressure. To sleep here is to be part of that long, unhurried story. There is no room on Earth untouched by motion. Even the quietest deserts shift their sand. Even the oldest mountains crumble grain by grain. Even the sea rocks, the ocean floor with tides you never hear. But in California, the motion feels more intimate. It belongs to memory. It lives in the stories passed down from the generations who felt the Earth turn in their walls, in their windows, in their hearts. To live here is to remember that permanence is an illusion, and that's okay. The fire beneath is not angry. It is not cruel. It is simply old. Older than cities, older than rivers, older than the names you gave the hills and coastlines. It shaped a land before language, before concrete, before satellite imagery, and it still does, with movements that do not need permission. It does not ask whether you're ready. It does not care for your timelines. It only moves, as it always has, underneath your feet as you sleep. There is something oddly beautiful in this truth. It's that you can rest, even when the ground does not. That your bones, your breath, are part of the same world as the molten rock miles below. That the quiet around you is layered with sound. It's with history, with tension, and yet you rest. There's comfort too, okay, in the fact that you are not alone. Beneath the vineyards, beneath the suburbs, Beneath the freeways and forests and fields of solar panels, millions of people sleep above the same fire. They dream. They breathe. Okay. They hope. And in the stillness between tremors, there is unity. A shared quiet. A shared sky. A shared ground. To sleep above fire is not to ignore its presence. It is to accept it. To build not in denial, but in respect. To prepare, not out of fear, but out of love for what you've built, for who you protect, for what still stands after every shake, and some things do stand. Time and again, the home that creaks but holds, the photograph that falls but survives, the neighbor who knocks to check if you're all right. It's a child who learns what to do in a drill and then sleeps soundly anyway. You see, fire beneath does not only destroy, it creates, it renews, it lifts mountains, teats, hot springs. It cracks open valleys where rivers now sing. Even in destruction, there is form. Even in pressure, there is transformation. Isn't that the story of all life? The next time the ground moves beneath your toes, if it's a tremor, a rumble, a quake, remember this: you are not small. You are not helpless. You are part of something immense and ancient and still unfolding. And yes, you can be ready, with reinforced beams, with thoughtful exits, with family plans and gentle courage, with the knowledge that the fire below is not the enemy, it is simply the breath of a living earth. And tonight, as you rest, the crust may whisper beneath your dreams, not to wake you, not to frighten you, just to remind you that even in the dark, even in the depth, even in the molten hum of stone, there is motion, there is memory, and there is life.